Okay, so let's do one last example here just to make sure that we fully understand what's happening. So this one looks a little weird because I just gave you one singular graph of the function f, and I do want to know a composition of functions here. It's just I'm composing the function f with itself, so it looks a little weird. But what we do want to do is, like we normally do, we want to check whether or not the limit as x approaches -1 of the inner function exists. So let's check if that in fact is true. And then once we do that, we need to make sure that the function is continuous at whatever the answer to this limit is. So, looking at our graph, hopefully you guys agree with me that the limit as x approaches -1 of f is 2. And so, since I got an answer as a number, then the limit does exist, so we're okay. And so our second check is to see, is f continuous at x equals 2? Okay, and so when you look at this graph, unfortunately it's not continuous at x equals 2. We do in fact have to pick up our pen off the paper at x equals 2, right? You do see it as we have the open circle, and then down here you can kind of see a gap right in the graph. So we would say no. And so that means that we can't just use that property from example 1 in the beginning of these notes, right? So instead we have to do this idea that we did in example 2, where we have to consider the left and right-handed limits of this composition and consider the inner function first. So we need to do the limit as x approaches -1 from the left of f of x, which, if you recall, we now need to consider the limit as x approaches -1 from the left of the inner function, in this case is f. So as we're approaching -1 from the left, you guys do see that we're approaching 2. And so we need to know, though, what direction we're approaching. So we have -1.5, -1.2, let's say, and then -1.1, and we're getting closer and closer to 2, which we got. Now here's the question, are we coming from above or below the y value that we're approaching? So we are coming from below in this case, right? Going back up here, see how these dots were all above our final answer, right? All of these y values were bigger than our final answer. In other words, we were coming from above, whereas these ones are all smaller than our final answer, and so we're coming from below, which means that we're technically coming from the left. Okay, so that's why I have the left symbol, coming from below. Okay, and again, you only need to do this. You only need to do this coming from below or coming from above and telling me that the limit is equal to something like 2 from the left or 2 from the right when you're looking at the limit of a composition of functions. Otherwise, do not worry about what direction you're coming from, above or below, in terms of the final answer for a limit. Okay. So we're coming from below, so then now I'm going to do the limit as x approaches 2 from the left of my outer function. Now what's weird is my outer function is again the function f of x. And so 2 from the left, hopefully you guys see that this answer is 5. Alright, now we need to do the limit as x approaches -1 from the right of f of x. So same idea, we need to do the limit as x approaches -1 from the right of our inner function, which is again f of x. And now again, what you see is from the right, we are coming from below that y value of 2. So we see that this limit is going to be 2, and since we're coming from below, again, this is coming from the left. And so when we do the limit as x approaches 2 from the left of our outer function, again, we're going to get that answer is 5. And so what we see is both the left-hand limit and the right-hand limit of this composition of functions is 5. So therefore, this limit exists and it's 5. Okay, so this is an example where we actually do get the composition of limits exist, even though we failed one of those two conditions and we couldn't use the property.